Hello everyone. In this video, we'll be understanding how to derive the trigonometric identities and then understand how to use these trigonometric identities. It's similarly as algebraic identities. We know that there are many algebraic identities like a plus b whole square, a minus b whole square, a plus b whole cube, a minus b whole cube, a cube plus b cube, a cube minus b cube, which are being used in many different various ways in mathematics. Similarly, trigonometric identities are also used in many different ways in different branches of mathematics. So we have trigonometric identities in this year. In class 10th, you'll be learning three major trigonometric identities. The first one is sine square theta plus cos square theta equals to 1. How to derive it? How did we get this formula? Or how did we get this identity is what I'm going to explain first, and then we'll understand how to apply it. So as you can see here, I've already taken a triangle ABC, right angle at B, angle A is theta, so that means BC is the opposite side, AB is the adjacent side, and AC is the hypotenuse. So first thing that we are going to do is we are going to say by Pythagoras theorem. Right? What I'll get, AB square plus BC square equal to AC square. Okay. Now in this one, I'm going to divide one of the sides to all the three terms. And in this case, I'm going to divide by AC square throughout. When I say throughout, means on the left and the right for individual terms. Okay. So now it's AB square divide by AC square plus BC square divide by AC square equal to AC square divide by AC square. So what will happen here? AC and AC square and AC square will get cancelled off. This will become AB upon AC the whole squared, and BC upon AC the whole square. I've just taken the square common. Now from this triangle, can I say sine theta? If I want to mark it out, it will be BC upon AC, right? And cos theta is, yes, AB upon AC. So can we substitute instead of BC upon AC as sine theta, instead of AB upon AC as cos theta? Yes. So here we'll get cos square theta plus sine square theta equals to 1, which can be read as sine square theta plus cos square theta equals to 1. So we have derived this first identity. Simple. We just have to write the Pythagoras theorem for the given triangle. You can take any name for the triangle and you divide individual side square by the hypotenuse. I've divided by the hypotenuse. So at the end of the day, I'll get opposite upon hypotenuse and adjacent upon hypotenuse. So that will give me cos and sine. Okay, so this is the first identity that we are getting. From this identity, we can make 4 more different parts. So how do I do it? First is cos square theta plus sine square theta equals to 1. So I'll shift the sine square theta on the right. So I may get cos square theta equal to 1 minus sine square theta. This can be used in many different situations. Similarly, I can say that I want to shift the cos square theta on the other side. Right? So let me write it again. So cos square theta plus sine square theta equals to 1. So I'm shifting the cos square theta on the right. So I'll get sine square theta equal to 1 minus cos square theta. Now, both the side, the cos and sine are in squares. So if I want to take the square root, so square root on the left will give me a cos theta, square root on the right will give me 1 square root of 1 minus sine square theta. Right? Similarly, I can say sine theta as square root of sine square. So it will be 1 minus square root of 1 minus cos square theta. So I have 5 identities right now. 4 of them are derived from the first. So cos square theta plus sine square theta equals to 1. Cos square theta is 1 minus sine square theta. Sine square theta is 1 minus cos square theta. Cos theta is square root of 1 minus sine square theta. And sine theta is square root of 1 minus cos square theta. Okay, let's go to the next identity. Tan square theta plus 1 equals to sec square theta. Again, let me label the opposite. adjacent and hypotenuse. Now in the previous proof, what did I do? I had divided by the, yes, hypotenuse, right? In this case, I'm going to divide by the, yes, adjacent side. So let's start. Okay. So first of all, we'll say AB square plus BC square equal to AC square, right? Now, which side is the adjacent side here? Yes, it's the AB. So I'm going to divide by AB throughout, AB square throughout. Okay. So what I'll get? AB square divide by AB square plus BC square divide by AB square and AC square divide by AB square. Correct? This will cancel off. Now let's use the triangle and find out what is the ratio AB upon BC. Sorry, BC upon AB is going to be and AC upon AB is going to be. So if I say tan theta, that is BC upon AB, right? And sec theta. What is it? Yes, it's AC upon AB. Hypotenuse upon adjacent. So this is 1. Let me write this as BC upon AB the whole squared plus equal to AC upon AB the whole squared. Correct? So now can we shift BC upon AB ratio as tan theta and AC upon AB ratio as sec theta? So are we getting 1 plus tan square theta or tan square theta plus 1 equal to sec square theta? That is our second identity. Again, as we got 4 subparts of that identity, here also we can write 4 of them. Right? First that we have to write is, I'll shift the tan square to the right side, right? So I'll get 1 is equal to sec square theta minus tan square theta. Okay. The next is I can shift the 1 on the other side. So I'll get 1 plus tan square theta equals to sec square theta. I'm shifting the 1. So that will give me tan square theta equals to sec square theta minus 1. Okay, now I'll take this, consider this. It's sec square theta equals 1 plus tan square theta. So a square root of that will give me sec theta equals to square root of 1 plus tan square theta. Right? Similarly, I can take tan. So that means square root. So square root of tan square will give me a tan theta and square root of sec square theta minus 1. So which are the 5 parts of this particular theorem? 4 parts. 1 is equals, sec square theta minus tan square theta equals to 1. That's how we read it, okay? And we remember it. Sec square theta minus tan square theta equals to 1. 1 plus tan square theta equals sec square theta. Tan square theta is equals to sec square theta minus 1. Okay? Sec theta is equals to square root of 1 plus tan square theta. And tan theta is square root of sec square theta minus 1. Right? The next identities, yes, I think you would have guessed right now. It's cot square theta plus 1 is equals to cosec square theta. Again, let me list the opposite, adjacent, hypotenuse. So in the first case, we had divided by the, yes, hypotenuse. In the next case, we had divided by the adjacent. So what's remaining now? We'll divide by the opposite side. So let's first write out the Pythagoras theorem. AB square plus BC square equals to AC square. Which is the opposite side? BC. So we are going to divide by BC square throughout. Right? So what we'll get? AB square divide by BC square plus BC square divide by BC square equal to AC square divide by BC square. This will go off. Now first let's understand here. Cot theta. It's adjacent upon opposite. So AB upon BC. Right? And next is cosec theta. Cosec theta is hypotenuse upon opposite. right? So I'm first going to write like this: AB upon BC the whole square. That's when I can substitute it. Okay, plus 1 is equal to AC upon BC the whole square. Now in place of AB upon BC, I'll write cot theta, and in place of AC upon BC, I'll write cosec theta. So I'll get the third identity, that is cot square theta plus 1 is equals to cosec square theta. Okay, now the remaining four parts of this. First, we'll shift the cot square theta. Okay, so cot square theta plus 1 is equals to cosec square theta. Shift the cot, so 1 is equals to cosec square theta minus cot square theta, right? The next case, I'm going to shift the 1 on the other side. Okay, so if I shift the 1 on the other side, I'll get cot square theta equal to cosec square theta minus 1. Now, from this one, I have cot square theta plus 1 is equals to cosec square theta. So, if I want cosec theta, that means I'm taking square root. So, square root 1 plus cot square theta. Correct? And here I'll be taking again square root. So, cot theta is equals to square root of cosec square theta minus 1. Okay, so the five identities are cot square theta plus 1 is nothing but cosec square theta. Cosec square theta minus cot square theta equals to 1. Cot square theta is cosec square minus 1. Cosec theta is square root of 1 plus cot square theta, and cot theta is square root of cosec square theta minus 1. So these are the complete list of identities that you have learned today. Now if you look at the major part that I want to highlight here is we have three identities with equal to 1. Sorry. Yes, and we need to remember them like that. Means sine square theta plus cos square theta equals to 1, sec square theta minus tan square theta equals to 1, and cosec square theta minus cot square theta equals to 1. Right? But the major important identities are sine square theta plus cos square theta equals to 1, sec square theta equals to 1 plus tan square theta, or the way it is given, and cosec square theta is 1 plus cot square theta. These are the three important identities through which you can get the other four, as I already showed. Now let's use these identities to solve simple identity based questions. Okay, so here, first question says 1 plus sine square theta multiplied by sec square theta equals to 1. First of all, trigonometric identity based questions are always solved like you start from left hand side, try to get your right hand side. Sometimes we start from right hand side to get the left hand side. Okay, so let me try solving first and second. Okay, so 1 plus sine square theta is cos square theta. Okay, sorry, we should start always LHS because which side we are beginning with. So LHS 1 minus sine square theta times sec square theta. So if you go back to identity, 1 minus sine square theta is cos square theta. Okay, so directly we'll put cos square theta into sec square theta. But we know that sec square theta is 1 upon cos square theta because it's a multiplicative inverse of cos square. So cos and cos gets cancelled off, equals to 1, that is our RHS. Right? Okay, the next question, we'll start again with the LHS, which is cos square theta into 1 plus tan square theta. So by now, 1 plus tan square theta, let's go up. What is it? Yes, it's sec square theta. Okay, so let's write down that. So we'll get cos square theta into sec square theta. Again, sec square theta is the multiplicative inverse of cos. So they get cancelled off. You get 1, that is your RHS. Right? Let's take the next one. Now, if you look into the identity 1 plus cot square theta, it is actually cosec square theta. Okay, so it is cosec square theta. Let's run up and see what it is. See, 1 cot square theta plus 1 is equals to cosec square theta, right? So now, cosec square theta is inverse of which particular sign? trigonometric ratios? Yes, it's a sine. So 1 upon cosec square theta is going to be, yes, it's going to be a sine square theta. And that is equals to 1, which is RH.